All right, guys. We are going to do a few things today. The first involves the practice sheet that looks like this. And so there are two questions to it, but this is the first question. You have a bunch of blank space right here. Here's the title of the paper, Dihybrid Cross and Beyond. If you are sitting in class right now with the substitute and they haven't given you this paper, you need to ask for it. You cannot move forward until you have this document. So pause and ask them to hand this out. It's on the front table in the tray with all of the AP Bio, like old copies. If you are a B student, you're at home. I've already given you this. And so you should have this. You need to dig it out of your folder. Okay, so we're going to start here. And we're going to look at a more typical scenario of a dihybrid cross question in AP. So the skill that you have done with like the guinea pig paper, that is all the same skill, but the language is kind of bumped up a little bit here. So let's look at this problem together, and I'm going to kind of get you rolling and you will practice it on your own. So this question says, in pea plants, yellow peas are dominant to green peas, and purple flowers are dominant to white flowers. That's important. That lets us know which traits are dominant and recessive. So when it comes to the color of the individual peas, yellow is dominant to green. And when it comes to the flower of the pea plant, purple is dominant to white. So kind of bank that in your memory for a moment. For each of the following parental crosses, give the predicted phenotypic ratio of the F1 generation. Show your cross. Now, we're only doing one, but I want to make sure you understand what this is asking. So we have to do the cross of the F1 generation. So remember, an F1 generation is when two parents are crossed together. And then we have to give a phenotypic ratio. So what do the offspring look like regarding the color of the pea and the flower of the pea plant? And so here is our first setup. We have a heterozygous, purple flowered, yellow pea parent. And we have a heterozygous, purple flowered, green pea parent. So if I look over here, heterozygous purple, that's pretty easy. I'm going to choose the letters P because purple is the dominant trait for flower color, and I know what a heterozygous is. But then I look at the second part of this question and it says a yellow pea. Well, yellow peas are dominant, and that means we could either be big Y, or we could be big Y, little y, and still show the yellow trait. So because it doesn't say, we assume that this term right here is applied across both traits. So this individual ends up being heterozygous for purple and heterozygous for yellow peas. This individual is heterozygous again for the purple flower, but is green pea. And so green peas are recessive, remember? So only one way to be recessive, only one possibility of a genotype. So think about, did you get heterozygous big P, little p, heterozygous big Y, little y for parent number one, and heterozygous big P, little p for purple, recessive for green peas. So these are the genotypes of the parents, and that's where we start. So if you haven't already, you need to write down the genotypes of your parents. Here's parent number one, heterozygous purple and heterozygous yellow pea. Here's parent number two, heterozygous purple, green pea. Now that we have our genotypes, remember we have to figure out what kind of gametes mom and dad can make. And so that's our FOIL method for each one of these genotypes. So for example, this parent is going to produce gametes that are big P, big Y. Also gametes that are big P, little y. They'll make gametes that are little p big Y, and they'll make gametes that are little p little y. And so take a second, pause the video, and write down the gametes that you think this parent and this parent can create. Once you have done them, come back and check your answer. But pause the video and do the work on your own. This is how we learn. This is how we practice. If you're back, let's see if you got these gametes correct. So here are all of the gametes that this parent can create. And here are the gametes that this parent can create. So once you have established your gametes, now we can actually cross them. And so doing the cross means we're going to put all of one parent's gametes on one axis and all of another parent's gametes on the opposite axis. And notice there is no chart provided for you. So you even have to draw out the 16-box chart. So take a moment right now, draw out the chart, and put your gametes on the axis and cross them. See how you do on your own with the cross. When you're ready to see the answer, come back to the video. All right, if you're back, I'm assuming that you have done this, and I really cannot relay to you the importance of trying this on your own, not just letting the video go forward so that you can see the answer, but really trying this on your own. If we were in class together, I wouldn't show you the answer until I had rotated around to make sure that we had tried on our own. So please, good faith effort here. Please make sure that you have tried it. All right, here is the cross. Now, don't worry about these little shaded spots. That's something that I use for myself when it comes to counting up the phenotypes in a second. But here are all of the gametes from the double heterozygous individual, the first parent. Here are all the gametes from the second parent, and here is their cross. So take a second and check. Check to make sure that you cross them correctly. It doesn't matter if you switch the gametes axes. It really doesn't matter. The offspring still look the same genotypically. So check yourself here. And when you're ready, move forward. The last part of this question asks for a phenotypic ratio. So let's pause for a second and think. What are the possible phenotypes? Well, we could be yellow or green for our P characteristic. We could be purple or white for our flower characteristic. So if I start to combine the possibilities, I could have yellow peas with purple flowers. I could have yellow peas with white flowers, or I could have green peas with purple flowers. And what's the last possibility? Green peas with white flowers. So I know that these are my possible offspring. This is what I'm hunting in the big cross that I just did. So pause for a moment and count up everything that you see that is yellow and purple. That's the dominant, right? Dominant for both traits. How many are yellow-white? That's dominant for the first, recessive for the second. How many are green-purple? That's recessive for the first, dominant for the second. And how many are green-white? Recessive, recessive. When you're ready, check your answers. Here is the ratio. So did you get this as your ratio for your cross? If you did, awesome. Good job. Expect and anticipate more questions like this. If you didn't get this ratio, go back a little bit in the video and check out the cross and see if you can spot maybe where you miscounted your offspring. Okay, so we've done a little practice. Now we're moving into something new. And so the bottom part of this worksheet is very unfamiliar to you. So before we do the bottom part of this worksheet, we actually need to take a few notes. So I'm going to ask that you pause the video and find your notes packet. We're going to look at the very next section, which looks like this. Okay, so once you have your notes packet out, come back and let's take a few notes and we'll finish out the practice worksheet after the notes. Okay, so if you are back, we need to talk about what are called polygenic traits. So, polygenic traits are traits that really involve multiple alleles at play. So, three or more sort of genes that are working together to create a particular characteristic. And so the example that I've given you here is skin color. Skin color is actually not coded by just two alleles, or, well, it's not coded by two genes, it's actually coded by three. And so anytime we increase, we've done monohybrid crosses, we've done dihybrid crosses. If we were to do a tri-hybrid cross, it would look like this. Okay, so the more traits we kind of add into a cross, the bigger the cross gets and the longer it takes to do, and the more of a time issue comes into play. And so College Board recognizes that and sort of accounts for it. And so what I'm getting ready to teach you is how to calculate probability of offspring when we get into 3 traits, 4 traits, 5 traits, 6 traits, and beyond. Okay, so we're going to switch to a probability calculation, and I'm going to show you an example. We're going to write down an example in our notes, but essentially, here's what we're going to do. If there are 3 traits, a tri-hybrid cross, we're actually going to look at each trait independently. And we're going to make a small 4-box cross for each trait. And then we're going to multiply the probabilities of those traits together to see what kind of an offspring we could create. So instead of the biggest cross you'll ever do here is a 4-box cross, and then you'll just multiply some values together at the end. So for example, if I said, here are 2 parents, here are the genotypes of 2 parents in a tri-hybrid cross. Okay, so let's make sure we understand what I just said. These are genotypes. This is a tri-hybrid cross. So we have trait A, trait B, and trait C. So we have a third trait involved here for each parent. If I ask you to do this cross, it would be huge, and it would take a lot of time to do that, an unnecessary amount of time. And so the question style changes when you hit a tri-hybrid and beyond cross. And so instead of the question asking you, what are all the possible offspring that these 2 parents could create, it will give you a specific offspring, and it wants to know the probability of these 2 parents making this specific offspring. So let's take these 2 parents, for example. Now I've handwritten this out. These are the same genotypes right here that we saw on the previous slide. So here are the 2 parents that we just saw. The question is not, what are all the possible babies they can make? The question shifts to, what's the chance that they can make this baby? And so that's a difference. When we hit 3 traits and beyond, we now no longer seek all the possible combinations. We seek a specific offspring. And so here's how we do that. We're going to look at each trait individually. So let's focus on the A's first. So I'm going to take the parent's genotype for just the A trait, heterozygous, homozygous recessive, and I'm going to cross those together in a small box cross. So here's parent number 1 that was heterozygous for A. Here's parent number 2 that was homozygous recessive for A. Here's all the possible combinations for the A trait that their offspring could possibly have. The question wants to know the probability of the recessive. And so once I've done this cross, I look at, half. Half of their offspring are going to be recessive for the A trait. Then I move on to the next trait in the parents, the B trait. So parent number 1 is homozygous dominant. Parent number 2 is a heterozygous. So I'm going to cross their B's together. And I'm going to look at, regarding the B trait, what kind of possibilities could their offspring look like? And then I'm going to check, I want to know the homozygous dominant possibilities, which is 1/2, right? 1/2 of their offspring with regards to the B trait will be homozygous dominant. Then I go to my next trait, the C trait. So do a little cross the C trait and see if you can get the right answer. Cross the C trait and tell me the probability of them having a recessive. When you're ready to check your answer, unpause the video. Did you get 1/2? So if you did these 3 crosses for the 3 separate traits up here in the parent, now the question is, what are the chances that the offspring is going to have recessive for trait A, homozygous dominant for trait B, and recessive again for trait C? So we figured out the individual probability of each of those. Now we just multiply them together. 1/2 times 1/2 times 1/2, right down here, gives us 1/8, right? So I think you all know that, but you just multiply the denominators. 1 times 1 times 1 is 1. And then the numerator, then you multiply the denominators. 2 times 2 is 4, times 2 is 8. So 1/8 of their offspring would have this particular genotype, which is what the question was asking. So pausing right there, I'm getting ready to ask you the probability of another genotype with these same parents. Okay, so here we go. Use the same parents and the same crosses that you've already done. Tell me the probability of this genotype. When you're ready to hear the answer, unpause. So do the work, do the math, and then unpause. Did you get 0% chance? There is no way when you do the cross that they can create any offspring that are homozygous dominant, right? So let's go back. There are no homozygous dominants in this cross. It is not a possibility. And so when I set out to do the math, this value is 0, and 0 times anything is 0. So there is a 0% chance that they could create offspring that look like this. So you should have written down in your notes and also copied the example down in your notes so that it's a good little memory trick and you can come back to it as you work through the second part of the worksheet. Okay, so now you have question number 2 at the bottom of this paper. You're studying 5 traits in pintids, an Amazonian flying beetle. You have identified each trait as belonging to separate alleles located on separate chromosomes. And here are the alleles, A, B, C, D, and E. So those are our 5 traits. After years of controlled breeding experiments, you have developed your pintid lines to the point that you can control their genotypes, which means you know what the parents really are. And so you perform the following cross. So here is parent number 1. Here is parent number 2. So using these 2 parents, you're going to make a small cross for the A traits, for the B traits, for the C, the D, and the E. And once you've done that work, you come back and do the probability calculations for each of these offspring. So these offspring, we want to know what is the chance that these 2 parents can have this offspring, and this offspring, and this one, and this one. So do that work on your own. Last thing that I'll say is don't forget to get a packet from the sub that is a practice set of questions for Thursday, Friday, and weekend homework. So if the sub has not given that to you, prompt him or her to give it to you because you must leave school today with it. Okay? So happy crossing today on Wednesday or Thursday if you're watching this at home as a B-Day student. So happy crossing. If you have questions, feel free to email me or you can remind text. Bye.